Hello everyone, my name is Syed. Today in this video, we are going to discuss about how to configure the E1 interface. So before the configuration, I'm going to explain you what exactly the topology I'm having here. Okay. So after that, we'll configure the digital trunk. That's the E1 interface we have. So I have a router. Consider this is the customer router. Then I have the PSTN here. Okay, in the PSTN also, see when we are grabbing a connection from the PSTN to the customer end also I'm having a router. Okay, here there is one router, that's a PSTN router, and another the customer router we have. So from this router to here, we have connected and we have taken this as a E1 interface. Which interface? E1 interface we have taken. Why? Because we are in India, we use the E1 interface. So now what happened? See, if you are taking the analog connection generally, okay, I'm taking the analog connection where the customer end we use FXY interface. That is the analog interface which is used to connect to the PSTN, this one. So in this connection, not required to do any configuration by default. Okay, but coming to this digital interface, okay, it's a mandatory we have to configure this one. Okay, without configuring, it's not possible to make the calls. Now the configuration comes on the both the end. The configuration has to be done on the customer end also. The configuration has to be done on the PSTN. So in production, what happened? The PSTN, the provider are responsible to configure their end. The other end, you are responsible as administrator. You are responsible to be configure that one. And so the configuration comes again. They'll be sending the files. The configuration file they'll be sending. According to that, you have to be configured. It's not like randomly whatever the configuration you want, you cannot configure that one. How the service provider is going to give some sample, okay, sample configuration. Based on that sample configuration, you have to be configure here. And in this configuration, not only this E1, even for the both T1, E1 almost same here. There are two types of configuration comes here. Okay, first one is the interface configuration. And second one is the D channel configuration. These are the two types of configuration we have to do manually here, this one. But in this class, I'm showing only the configuration part here. I'm not doing any kind of the test call later because after configuring this one, again, we have to create a dial PS. Still, we have not discussed in detail about the dial PS. Next, we have another class. It's called dial PS. Okay, so what is dial peer, which already we have discussed. There are different types of dial peers. We have this one. So there you have to create an outbound dial peer, inbound dial peer. After discussing the dial peer class, then I'm going to show you the same setup. I'm going to do the test call. So I'll be taking one phone here internally, another phone in the PSTN. I'm going to make a call from internal to external or external to internal. In that, we are going to be do the testing for this one. But today we just configuring this E1 interface, both interface configuration as well as the D channel configuration. This is how I'm having two routers, E1 interface I'm having. I'm connecting from the customer to PSTN. Got it? This is my topology I'm having. Okay, now let's get into the configuration first. So for this, I'm going to access my putty. See here, I'm having two routers, 201, that's my customer router. So I'm into the customer router now. This is my customer router here. Okay. So before you configure the digital interface, E1 interface, okay, what happened? There are configuration we have for the digital interfaces. Okay, before to that one, for an example, already that's a separate module. T1 E1 is a separate module that has to be inserted on the router. By default, you take the Cisco router, you will be not getting this modules, T1 E1 interface, this one. That separately we have to, like how the analog interfaces we have separate module. Similarly, we have to purchase the T1 E1 module and we have to be insert on the router. So after inserting that router, now you have to be check it out the status of that interfaces. How you are going to be check it out? For an example, you have the serial interface or the Ethernet interface you have. How you are going to check it out the status of the serial or Ethernet interface? Exactly. Show IP interface brief. This is the command you are going to be use this one. So when you are giving this command, so if you have any serial interface or Ethernet interface, it will be display here. So what IP address, what is the status, everything it will be display here in this one. So the show IP interface, this is the command we can use to be verify the serial, loopback, and Ethernet port. Now, if you have an analog interface, which command you are going to be used to verify the status of the analog interface? Show voice port summary. This is a command you can be used to be verify your analog interface. See, now we have the two analog interfaces, 0/3/0, 0/3/1. That's my FXS interface here in this one. Okay, now to verify your digital interface, how you can verify? Which command you are going to be used to verify your digital interface? Show controllers E1. If you have a T1, you can type T1. If you have a E1, you can type E1. Show controllers E1 here, this one. Now you can see this one. So I'm getting an output here, this one. E1 0/1/0, E1 0/1/1. Sometimes what happen, it will not display anything. I'm executing this command, show controllers E1. Whatever the output you have now here, you will not get anything. It will be getting blank. It will be like next line, that one. Okay, that means if there is no digital interface or inserted on the router, obviously, even if you type the show controller E1, it will not display any information. But my interface is inserted on the router, but still it's not displaying. When I execute this command, show controllers E1, my interface is exists in the router, but still it's not displaying. Okay, in that case, what you have to do, first you have to be verify whether exactly that interface is inserted or connected or not in the router. For this one, what you can do, this one, show inventory. Just type the show inventory. Okay, in the inventory, what happened here, you can see this one. See, this is the inventory means exact motherboard and what is this, what exactly router series, serial number of the router, how many modules you have, which module, what exactly interfaces are connected, every information you will be getting from the inventory here, this one. So this is my 2821 chassis router, Cisco 2821, and this is the, where it is, SN. SN means serial number. This is exactly serial number of my router. Suppose from here you can find the serial. Why we require the serial number? Whenever you want to open a tag case, okay, the tag case can be opened by the using the serial number here, this one. Okay, so that's the reason. Now here you can see already I'm having VVIC C2 2MFT T1 A1 interface, which we have inserted on the router, which is comes in the 0. Okay, on slot 0 subslot 1 we have this one. Can you see this one? Okay, so we have that interface. So now you go to the another one, 0/3, we have the 2FXS interface and PVDM also. Okay, later we are going to be discuss what is the PVDM. Okay, so PVDM, it's onto the slot 0 subslot 4 and the PVDM 264 we have this one. What is this PVDM DSP? There is a separate topic on that one. We'll discuss on that one. Yeah. So now you can see this one. Yes, the T1 E1 interface which is connected on the router, but still when I'm executing this command, show controller E1, nothing is coming here. So for that one, what we had to do here, sometimes router is not going to detect that E1 interface automatically. Nowadays, latest, whatever the router you are getting, okay, any series ISR generation 2 router or generation 4 router, even if you insert your digital interface T1 E1, it will not detect automatically. But in the inventory, it displays if you verify. But when you type the show controller, it will not display anything. For that, what we have to do, we have to execute few commands. Already I have done here in this my router. Okay, this is the command you can type. Card space type space which one? E1 T1. Okay, that E1 is exactly under which module? 0/1. Okay, 0/1. Why I'm typing this 0/1 here? So again, if I go back to the show inventory, so this is the 2MFT T1 E1 interface, which is on 0/1. The same thing I'm executing here, 0/1. Can you see this one? 0/1. So after executing this one, now router is going to detect that interface. After that, if you go and if you type show controller E1, then it's going to get the output here. This one. Got it? This is the first thing you have to do it here in this one. And another thing, okay, before you configure, but this one, how the E1 is going to be detected on the router. So after that, okay, there is another mandatory configuration we have. This is the one, network clock participate. If you remember, okay, yesterday there are network clock, global configuration has to be done. Okay, why? Because sometimes if it is missing the packets or times are missing here in this one, to synchronize properly from one device to another device, we have to be configure the network clock participate. So now here you have to be defined, because this is the router. In a router, which exactly interface is responsible to be participate for that one, that has to be configured. Again, this is the mandatory configuration here. So you have to execute network hyphen clock hyphen participate. Okay, which one you are participating? WAN interface card 1. Okay, then select, you are giving the priority here. Maybe you will be having the multiple E1 interfaces. Any one you have to be select. Okay, priority select 1 E1 0/1/0, and this is the mandatory you have to be configured. If you are not configuring this one, other configuration it takes, but call will not establish. Call will not establish here this one. Got it? So this is another configuration has to be done. Now, after configuring all these things, now first what you have to do, get into the global configuration mode. Okay. So here, now you got the controller, right? Show controller E1. So what is the module number you are getting? E1 0/1/0, you are getting that one. Now you have to get into this one. Okay. Before to that one, ISDN. Switch type you have to be defined here. Okay, there are many switch type. This is the standard, depend on the country here, this one. Okay, before you configure the E1, see, there are three different. One, interface has to be detected, network clock has to be configured, third one is switch type has to be defined. After configuring all this thing, then only you have to go to the next configuration of the digital interface, that one. Okay, now how you are configuring this switch type? This is the standard for every country here. So now always we configure the primary NetFi here, this one, because this primary NetFi we use for UK, Europe, Asia, and Australia. Now India comes under Asia. So always we use what? Primary NetFi. This is the switching method. Okay, we are using primary NetFi. Okay, now I am going to get into the interface. Controllers E1 0/1/0. Enter here this one. Now we have to configure first line code. Okay, let me configure framing. Framing here. See, we have two options: CRC4, no CRC4. Okay, I'll just configure CRC4. Framing. What is framing? It defines how exactly it's going to route the bits. Okay. Next, we have to be configure line code. Okay, line code. So now AMI I'm having, HDB3 I'm having. I'm going to be configure HDB3 here, this one. Then after clock source. Okay. The clock source, you have line internal. Which end I'm configuring now? Customer end I'm configuring. Whenever you are configuring the customer end, always it should be line. Always it should be line here, this one. So line here. Okay. Framing, line code, clock source. Now we have to be configured PRI group, PRI space group, time slot. Okay. Now here we have to define which interface is this one, T1 or E1? E1. In E1 totally how many interface we have? 32 we have this one, 30 we will be using. But still, whenever you are configuring either T1 or E1, automatically it will not take all the channels. Manually, you have to define that how many channels you want to be use it here. For an example, I am going to take only 10 channels. 1-10 means totally 10 channels I am taking here, this one. Okay, before I'm executing this one, I want to show you one more. Okay, so I'm into the global configuration. So that's the reason I'm the do command I'm using. Show IP interface brief if I'm using here this one. Can you see this one? Only two interfaces I'm having, right? Gigabit Ethernet 0/0 and 0/1. Okay, we'll come back on that one. So now again, I'm configuring PRI group, time slot, 1-10. That means my requirement is only 10 channel. If your requirement is 30, then you can define the 30 channels. Okay, that's how you have to. It's not going to select automatically the channel. You had to configure or define the manually that one. Until you are not defining, it will not take it here, this one. Okay, so that's it. If you want to enforce, generally enforce, we are not configuring for the even, we are configuring for the even here, this one. So PRI group time slot 1/10, enter. That's it. Now this is the interface configuration. Now what happened if you come out here? See, when I was verifying the show IP interface brief, only 2 interface was there. Now let's verify now here, this one, show IP interface brief here. Can you see this one? Now it's created serial interfaces. Always the channels we have, right? 10 I have specified what channel. The channel, it will be created as a serial interface. Okay, and always you can see what is my exactly module number 0/1/0, right? See 0/1/0:0. That means that's the channel 1. Channel 2, 3, 4, 5, 6, 7, 9, 8, 10. 0 to 9, how many? 10. Always it starts from the 0. Okay. And if you remember which interface we are using? E1 interface. And in the digital signal, we have 2 signaling methods. Which are those? CAS and CCS. Okay. In the CCS, what happened? It's going to dedicate one channel for signaling. Which channel it is dedicating for the signaling? 16. So can you see this one? See, I have given 10 channel. 0 to 9 is a 10. Automatically, one more channel is created. That is a 15. 0/1/0:15. This is the 16 channel. 0 to 15 is 16. So this is your D channel, which is created automatically. It's not required to specify that one. It's going to create it automatically. Got it? Clear? Clear, everyone? Okay. So one thing I forget here. You have to give no shutdown. You have to give no shutdown. After this, now you get into this interface. D channel. Why? Because without configuring the interface, we will not get this D channel. So now interface serial 0/1/0:15. Okay. Now here we have to configure switch. Oh, sorry. ISDN switch type. Here also we have to define. On global configuration, we have to define the switch type, and also we have to be define the switch type under the D channel. Okay. Switch type. What is my switch type? Primary net file. Okay, fine. It's asking to be shut down this one. Again, I'm going to execute. See, it has taken here. Interface must be shut down before configuring the switch type. Yes, I have shut down and configured here this one. One thing. Next, ISDN protocol emulate. Okay. So one we have the network and another one we have the user. So I am always user, provider end. Sorry, customer end. So user. Another end, it should be network here. Next, ISDN protocol emulated. Then P channel number order, ascending, descending we have. Always my end, it will be ascending. Okay. What is this ascending and descending here? For an example, between your customer router to the PSTN. So this is the customer router and this is my PSTN here. We are configuring here. So totally how many channels we have? 10 channels. 10 channels we have taken here, this one. Suppose from customer end, one user is trying to make the call. Now the router has to provide one channel. Okay, it's going to provide the channel 1. From the channel 1, it will be connecting to the PSTN, call will be connected. At the same time, okay, another user is dialing from the outside to inside. The call is hitting into the PSTN. Now PSTN has to provide the channel, right? Even if it's going to provide the channel 1, what happened here? Glare happens, right? So to avoid this glare, what we have defined here, this one, this configuration has to be done ascending, descending. So ascending means always it comes from the lower to higher, this one. Whenever if the descending other end has to be configured, whenever if the PSTN it comes, it will be providing the channel 10. Okay, this is the concept of that ascending and descending here in this one. Getting everyone this one. It's very simple. There is no rocket science, nothing here. Next, ISDN. Incoming voice. In this one, what we are receiving? Voice traffic we are receiving this one. Then we have to give no shutdown. That's it, the configuration of digital. Yes, it's already done. First, we have to define the switch type. Then we have to be define this one, protocol emulate. Then B channel numbering order, which we are receiving incoming call, no shutdown here. That's it, the configuration of your E1. So this is what? Two configuration. Interface configuration, D channel configuration. So it's not possible to do the D channel without configuring the interface, because after we execute that command, then only the serial interface generates here, this one. Okay, I'm going to save this configuration. So that's it, the configuration I have done. Now what happened here, this one, you can verify this one. For example, show ISDN status. If you type, obviously, here, layer 1, see, ISDN works in a 3-layer architecture. Layer 1, it's active. Layer 2, now I'm getting error here, this one. It's very important whenever you're troubleshooting. Okay, so yeah, obviously if the layer 1 is shut down, no active something, then there is a problem with maybe the configuration problem or the physical interface problem. It can be anything. Okay, the layer 1 is active and layer 2 is here always multi-frame established should be get. Multi-frame established, then only your connection is good. Rather than multi-frame established, tie assign. Okay, if you are getting, your connection is not good. Why? Because now I have configured only one end, another end I have not configured, right? Yeah, so that's the reason. So it's getting the error. Obviously, if the layer 2 is down, layer 3 also no active false. Getting this one? Okay. After this one, you can type show controllers E1. Here you can see that E1 0/0/ is 1. Okay, then we have configured framing CRC, line code HDB3, clock source, line we have configured. Can you see this one? Okay. Now I have to be configure under the another end, that's a provider end here, this one. So that's this is the PSTN router. Let me get into this one. Okay, here also we have to do the same thing. Okay, first show controllers E1. If it is not getting, what you have to do here, this one, card type has to be configured. That you'll be getting from the show inventory here. So here also I have configured card type. Here also I have configured network clock participate. Okay, then I have to go to the global configuration mode. Then I have to specify ISDN switch type primary net file. Okay, next after this one, we have to give interface. Sorry. Controller E1 0/1/0. Okay, here I had to configure framing. What framing I had to be configuring? So one thing you have to remember here in this one. Okay, so again I'm configuring the framing is CRC4. Then line code is HDB3I. I'm configuring. Then clock source I'm configuring. Now this type it will be an internal. Okay, see. You have a customer and line. This is the customer and this is the PSTN here. So both the end, you have to configure framing first and line code, then clock source. Got it? Framing and line code, it should be same both the end. Okay, see here, the framing I have configured CRC4 here. Other end also I have configured CRC4. Okay. Then line code. Line code I have configured HDB3, other end also HDB3. But when coming to the clock source, it should be a difference. One end it should be line, another end should be internal. Okay. Where is internal? Where is line? Always customer end line, provider end internal. So now here, this is my provider end. See, can you see this one? This is the PSTN router. So I have configured the internal here, this one. The other end I have configured line. So you had to remember this one. Framing and line code, it should be the same, but clock source, one end it should be line, another end should be the internal, this one. Got it? Okay. So here also, if you verify before you execute that PRI group, okay, do show IP interface brief. Here we go. We don't have serial. That's a physical 0/2/0. But now I'm going to be configure PRI group time slot 1/10. It should be the same. Why? Because it should be the same. Otherwise, it will be create some problem here. Okay. Time slot 10. That's it. Now, if you come, show IP interface brief. Here we go. See 0 to 9. That's a 10 channel, and this is the one D channel is created here. This one. Got it? Now, what you have to do? Interface. Get into this one. Serial 0/1/15. First, you have to type ISDN, switch type, primary, net5. Next, ISDN. ISDN what? Protocol emulate. Okay. So here I have to be configured network because other end I have configured the user. Then ISDN, B channel, number order. So what you have to configure? Descending. Other end I have configured ascending here. Then after ISDN, incoming voice. Then after no shutdown. And also I forget one command. No shutdown here. That's it, the configuration. Here, show controllers E1. Now you can see this one, where it is framing line code. It's taking line, no problem. Now, show ISDN status. Here we go. Multi-frame establish. Always the layer 2 should be multi-frame establish. Okay. Now, go to the other router now. That's my customer end. Earlier, when I was checking, it was down, right? Tiazen. Okay. Now, show ISDN status. Here we go. Got it. This is how we can be checking out the ISDN status. In an interview, they are going to ask about how we can check it out the status of the ISDN.
Layer 2 multi.
No, this is the command. Show ISDN status. In this one, layer 1 should be active, layer 2 should be the multi-frame established. Okay. Then after, if you want to continue, you want to give the answer, you can elaborate, you can give it. If you stop, okay, rather than multi-frame establish, what other error you'll be getting? Okay, tie assign. If it is a tie assign, how you are going to troubleshoot? So this is how you'll be getting a different questions on the ISDN, and it's very important. Okay, because what happened as per the interview also, it's important even for the calling also. So you have the E1 interface, the calls are not connecting, incoming or outgoing calls are not connecting. You have something issue with an ISDN or issue with a provider. So you have to verify many things that one. Yes, we'll be see that troubleshooting part in some other classes that one. Suppose the ISDN is not working, what exactly you can verify that one, what command you can use it. We have a step by step. What is the step one, what we have to do? What is the step 2? What is the step 3? How you can collect the logs, how you can enable debug, show command, verification commands, and all this thing that we will look into some other different tasks. So that's it, the configuration of the ISDN. This is how we have to do the ISDN configuration. That's what. In the analog connection, simply just connect the cable, automatically it works. There is no any configuration, mandatory. Yes, we have done the configuration. That's a customized configuration, but it's not mandatory. But here in the digital interface, mandatory you have to do all this configuration. Until you are not doing this configuration, your interface will not come up. When it is not coming up, no calls works. Clear? So that's how we are going to be. We'll create the E1 configuration. The same thing we can be configured for your E1. Sorry, T1.
After this, we need to configure the directives.
Yes, yes, yes. But today I'm not covering that type here. We'll cover some other day. Okay, so let's see that one. On that day, I'll show you a few things we have to be configure on. I'm just saving that configuration. If you want to do the practice, yes, you can do it the practice. But okay, don't save that configuration. But before to that, you have to remove this configuration. Okay, first you have to remove that configuration, then you can do that configuration. Okay, so that's how we have the digital interface configuration. Clear? Any doubts, any questions? So that's what the configuration, if you remember. Same thing we have done, right? Okay. Then after we have done this is example I have taken for T1. ISDN incoming voice, switch type, protocol emulated. Okay, network. Any doubts, any questions? Because I'm expecting one question here. So that's the reason I'm asking you guys. If you remember, whenever we configure the digital interface, either T1 and E1, there is the two signaling methods we have. Yeah, more than two sig and FAS also we have, if you remember. So example, CAS and CCS we have, right? CAS, if you work, it's going to rob the bits. CCS, if you implement, it's going to dedicate the channel here, this one. But I have not mentioned anywhere whether I'm using CAS or CCS, right? Huh? Yes or no? You got it? Where that's mandatory configuration, right? But I have not mentioned anywhere whether I'm using CAS or CCS. Is it correct? No. Because I have mentioned actually that one. If you remember, okay, example, I was getting into the E1 interface, framing I have configured, line code I have configured, clock source I have configured. Then here there is a command DSO group. Can you see this one? Instead of that, I have configured PRI group. PRI group, time slot, 1 to 10 I have given. This I have not mentioned. Okay, not required this one. PRI group I have given, right? So whenever, now here in the slide, you have a DSO group. What is the difference here? PRI group, DSO group. Whenever if you mention the PRI group, it takes CCS signaling method. If you mention the DSO group, it takes the CAS signaling. This is how we define whether we are using CAS or CCS.
But CAS is not.
Yeah, it's up to you. If you want to use, you can use it. Got it? If you type DSO group, which signaling method it takes? CAS. If you type PRI group, CCS. But I have configured PRI group. So that's the reason it's dedicating one channel, D channel I'm getting. Getting the point? 16 channel. Clear? Okay. The next call flow, which we have already done, ISDN call flow here. Okay. Next, we'll discuss about the PSTN. What is PSTN? So many times, every day I'm using a word PSTN, central office, PSTN, central office, something like that. So what is this PSTN? Okay. PSTN, public switch telephone network. Okay. it provides infrastructure and service for public telecommunication. In your home, there is a telephone. Okay. In your friend home also, there is a telephone. Between your home to your friend home, through the telephone, if you want to communicate, so connectivity is required, right? Yes or no? Something devices are required, cables are required, it has to be transmit the signals, everything that one. Who is going to manage all this infrastructure? Provider. The PSTN is going to be managed that. That is what? It provides infrastructure and services to establish the call or connect the call from one end to another end globally. Not only here, okay, anywhere. I'm sitting here in Bangalore, my brother is in Dubai. Okay, I want to dial to my brother who is in Dubai actually. So there the provider is different. In Bangalore, the provider is different. But still, in backend, what happened? One provider to another provider, there will be a connectivity. Okay, so through that one, what we can do, we can able to be establish the connection and communicate to my brother that one. So that is what PSTN. PSTN, it's a provider. Whatever the necessary infrastructure services, infrastructure means what? Devices. Where you require routers, switch, or any other cable, whatever the connectivity, whatever the any other devices, that's what the infrastructure. It's going to be provide that infrastructure and services. Next, it provides both analog and digital services. The PSTN, if you want analog connection also, it provides digital service also, it will be provided. If it is analog connection, we will be terminating on the router with the FXO connection. Digital, we have the PRI and BRI. Okay. Again, T1, E1 comes under the PRI connection. The different digital services. Already we have discussed about the analog, right? Analog only FXO we have, Gamma we have, ENM we have this one, that but we are not using that one. So the different digital services, what digital services we have? DSL, but nowadays we don't have this. Earlier, when you are taking the internet connection, you'll be getting that internet connection through the DSL connection. Okay, that is what DSL, digital subscriber line. It provides the internet access by transmitting digital data or local telephone network. Means how they were providing. First, they'll be grabbing the telephone cable. Through the telephone cable, you'll be getting internet as well as the this one calls also this one. That is a DSL. After that, ADSL has come. Okay, DSL, ADSL connection. After that, now the latest we are using FTTX, fiber to the home or office. Now for what happened, this one for the calls, internet, everywhere we are using what? Fiber connection we are using. Okay, then we have the ISDN connection. Now your T1 and E1, which comes under the ISDN. Okay, ISDN stands for Integrated Services for Digital Network. So in interviews, sometimes they'll ask what is PRI or what is ISDN also. Okay, PRI also primary rate interface. Then you have to explain T1, E1, the differences between that. Even in the interview, they'll ask about what is ISDN. ISDN stands for Integrated Services for Digital Network. It is a set of communication standard for simultaneously can transmit voice, video, and data. It is a set of communication. We use this ISDN for communication. Simultaneously, we can do voice, video, data communication in this one. Okay. Next, the different access interfaces are BRI and PRI. Again, this BRI, PRI comes under the ISDN. Okay. Then what is PRI? Primary rate interface, BRI basic rate interface. In the BRI, we get 3 channels. PRI, we get 2 interfaces, T1 and E1. That's how you have to be explained. So now here, BRI basic rate interface, it provides a 3 channel 2B plus 1D. B channel is consists 64 kbps and D channel is consist of 16 kbps of bandwidth. The PRI already we have discussed in the last class. What is the PRI? What is the T1, E1, channels and everything, bandwidth and everything we have discussed. Clear? So this is about the PSTN. Got it? Now ISDN, it's a digital service provided by PSTN. So what happened here? We can call it T1, E1 also, PRI, T1, E1 also, or ISDN, PRI, T1, E1. All are same. So next we'll discuss about the PSTN numbering plan. PSTN numbering plan here, this one. What is this numbering plan? Is very, very important. Without this numbering plan, it's not possible to make any calls. Either it's incoming call or outgoing call here. So before we get into this one, I want to give you a small intro about the IP address, which already I have explained you about the IP address. If you remember, we have two types of IP addresses.
Version 4, version 2.
Private IP address and public IP address. Okay, so this is my internal network, LAN network. Okay, here multiple devices I'm having. Then I'm using one router here because in the LAN, this is the WAN. So this is my ISP, Internet Service Provider. I'm grabbing a connection from the ISP to my customer. This is my public network, right? And this is my private network. Internal network, LAN network is the private, and the WAN is public network. Now, internally, I'm having multiple devices. Okay, you can take anything, computer, laptop, desktop, server, any other device, anything you take. Okay, so we have three classes we are using. Okay, class A we are using, class B we are using, class C we are using. If you take the class A, B, C, they have reserved some IP addresses as a private IP address. If you go to the 10 class A, 10.0.0.02, 10.255.255.255. In a class B, 172.16.0.02, 172.31.255.255. In a class C, 192.168.0.02, 192.168.255.255. So this is the range in each class they have reserved as a private IP address. That means any of this class, A, B, C, internally you can use it. And this, it's a free of cost, not required to pay for anyone. Right? For an example, internally I'm using this IP address 192.168.10.0, and this network I'm using 10.1, 10.2, this one. Now, what type of IP address is this? Private IP address. But whenever if you want to go outside in the public network, if the traffic is hitting on the router, from the router, if you want to be reach ISP or public network, wherever you want to communicate, then you require what IP address? Public. But what IP address you have here? This one. Private IP address we have. Is it possible to communicate with a private IP address? No. Always the traffic has to be flow via public IP address only. So then we have a separate concept over there in the router where you can configure NAT, network address translation. Okay. So NAT, what happened? It will be taking your private and it will be mapping to the public. Okay. Then it will be sending. If any traffic coming from the public, again, it will be converting and it will be NAT translation happen to the private. This is how it communicates that one. That's a purely the networking concept where again, you guys are not going to be implement or configure work on that one. The network administrator is going to be configure all this thing. Okay. You got it now, this one? Yes. What is then private and public? Okay. Similarly, coming to the telephone infrastructure.
So do we need any separate subscription on the internet?
No, that we are configuring the NAT on the local gateways. On firewall, layer 3 switch, router, we can be configured. Not required any services to be purchased for that one. Now coming to the telephone network here. Okay, now I'm having what? PSTN. Then same router I'm having. Okay, I'm having, it can be any connection, analog or digital. Let it be any connection, this one. Okay. Now internally I'm having phones. Now any phone you can take. Either you take analog phone or IP phone, any phone you take this one. For example, I have IP phone, analog phone, all the different phones I'm having. Okay. And its extension internally we have given what? 3-digit, 4-digit, 5-digit, 6-digit extension we have given, right? For an example, if you remember internally we have given 601, then
1002, 2001.
2001, something we have given like this one. Now, somewhere here in the PSTN, there is one number here. Okay, 98454999012. Okay, this is the number. Now, I want to dial from this my IP phone to this number I'm dialing. So what happened here? This one, it will be coming, it will be hitting. Then it goes to the, from the router, it connect to the PSTN. From here, it will be connecting. Well and good. Okay. One scenario. Actually, the call will not establish here in this one. I'll come back why it will not establish. I'll explain you this one. Correct? At the same time, this user wants to be communicate. This user wants to communicate to this one. Now, what this phone's extension is? 6012001. When this from this phone, if the user is dialing 6012001, when the call is coming to the PSTN, and it will be getting dropped here. This one. Because whatever this number you have 6012001, this is not a valid number. For example, in your organization, you have used 6012001. If any other organization, if they were using the same number, then how it's possible to route that number? Is it possible?
No.
It's not possible to possible. Got it? So, whenever you want to communicate over the PSTN, it should have the valid number. For that valid number, we call E.164 number. Always your number should be into E.164 pattern. The number should be into the E.164 pattern. Got it? What is that E.164 pattern? How it comes? Let's see in the slide. You got it, the concept? So whenever you have assigned like a 3-digit, 4-digit, 5-digit, 6-digit, 7-digit, that's not in a valid numbers. That, yes, we are assigning still the 3, 4, 5, 6 internally, that for only for internal communication, that one. But to make external call or to receive the call, always it should be a valid number. Okay. If there is no valid number, then it's not possible to no incoming call, no outgoing call. Both it will not work here, this one. Okay. Data network, the same thing. If you remember the private network, public network, same thing we have. Again, I'm not explaining this. I'm skipping this point. Organization managing their own internal telephone system can develop any internal number scheme. The best fits the company needs, similar to private IP address, right? Internally, what happened? Internally, maybe they can go with 3, 4, 5, whatever the number they want, they'll be setting, but that we use only for the internal communication. Okay. However, when connecting to the PSTN, you must have a valid E.164 standard address for your telephone system. Got it? E.164 is an international numbering plan created by ITU. ITU is the organization, International Telecommunication Union. They have designed this number here. So in this number, you will be getting country code, national code, and subscriber number. Okay. Example here, this one. Can you see this one? This is how we'll be getting, right? +91. That's a country code. India country code is what? +91. +1. It's America, that one. Okay. +44. Spain. Got it? +86. China. +85. Hong Kong. So that's how we have the country code for every country code. +97. Qatar. +97. Got it? This is how we have the country code. See now, +9197. The next 2 digits it describe what type of number is this, because you have fax number, landline number, mobile number. It describes this is the mobile number. 97. Next 3 digits 480. It describes who is the provider. Who is the? We have Airtel here, BSNL, Geo. There are many other. We have this one, right? So it will be describing who is your 480. This is the Idea Karnataka. Okay. Next 288890. That's the subscriber number. This one. This is how, whenever you take any number in that one, country code should be there, national destination or area code, and subscriber should be there. Then it is into the this is the E.164 format. If you want to route the call over the PSTN, always your number should be in this format. Then only it's going to be routed. If it is not into the E.164 format, straightforward, it's going to drop the call. It's going to drop the call. It's not going to be routed anywhere, this one. So that is what numbering plan. Got it?
Then how it will convert to local?
That you have to configure. Manipulation has to be done.
Digit manipulation.
Digit manipulation. Got it? So what is the PSTN numbering plan? Clear? Any doubts? Any questions in this? What is PSTN numbering plan?
In the four formats are there. 91 country code, 97 national destination.
No, 97 example here, national destination or area code 97480, both its combination. But generally, I have decode that one. First two number which indicate what type of number, next three digit which indicates who is the provider, next five digit it indicates the subscriber number. Somehow, country code and 10-digit number has to be covered. Then only it's a valid number. Sometime we get 9-digit also, 10, depend on the country that one. Different country, they use the different format they have. Means not format is the same, but numbers, how many numbers? 8-digit comes, 9-digit comes, 10-digit comes. That's how we get it here, this one. There are many other things comes here, this one. Sometimes what happened here, the provider will not accept with, see here, the plus is the standard, that's it. But some provider, what happened, this one, they'll not accept this plus, they'll accept 0. Okay, so that's a depend on country to country. Country to country. And that is what, so whenever you are configuring in the production network, what happened, you have to be understand that one. See, that is what, generally what happened here, whenever you are learning the course, not only this course, you learn any course. Okay, technical course, whenever you are learning what happened, this one. See, today I'm explaining you about the PSTN numbering plan. Say I have given plus 997 something, this is how the number it comes, this one. But when you go to the production, it will be a different. It will be not like a same as like this one. Yes, it will be a different there here. So that's the reason. Now we have discussed about the even interface configuration. Even interface, what happened, this one, something, the standard configuration, something we have taken, configured both the end. Yes, it's working. But if you go to the provider, there will be something different configuration sometimes, not in every time. This is what the difference actually. Whenever you are learning the concept, what happens here, it will be a something only, it's like a reference. Okay. It will be not the same in the production sometimes, but it's not like, I'm not telling like completely 100% it will be changed. Few part what happened, it will be get changed here in this one. Okay. That is what, when you are working, you will be understand this ones. Okay. So that's the reason, simply by watching the video in the YouTube or going with the Google. So what happened now, this video also I'm uploading in the YouTube, this one. So with this one, what happened here, this one, yes, they'll get some knowledge, idea, something on that one. But by watching this video on the YouTube and they want to be go in the company, they want to crack the interview, they want to survive, they want to understand how internally the infrastructure they have or the configuration comes, it's not possible. So that's the reason you have to attend the trainings, where all this type of we'll be covering under in the process classes, mock interviews and everything that real-time classes. This is what we are going to be covering. Clear? All right. So next, VoIP. So if you remember in the telecommunication, first we were having what? Analog. Next, digital we have. Now we have the VoIP. This one. See, earlier it was like this one, the waveform, right? Then after,
zeros and
so zeros and one.